Good morning. Time is 2 o'clock on September the 1st, 2020, and we're imaging Mars. If you look up the night sky after midnight, you'll see a very bright object shining here between the fishes of Pisces. This is, of course, Mars. It's going to be very well placed this year. And towards the end of October, we're having a National Astronomy Week when we will be focused on Mars. Quite a favourable opposition this year. Mars will reach a size of about 23 arc seconds across. And the main benefit this year will be at its high elevation. It's currently at 40 degrees altitude, and this little image here was a live picture taken through Celestron 9 using an ASI ZWO 120 color camera. So the seeing conditions are quite good tonight. You can see it is moving around a little bit, but it's not too bad. It's not a complete jellyfish like it is some nights. So we should be able to pick up quite a bit of detail from the planet. So what I'm going to do, I'm going to run through the steps I take to process this image. This is about 2,000 frames caught in about a 30-second exposure. Obviously, you can see a little bit of detail on Mars, some dark banding here, a brighter south polar cap, which has been shrinking for the last few weeks as Mars approaches its springtime. So the first steps I take, this was captured in a little program called SharpCap. I'm now going to call up this program called AutoStacker. And I've loaded my Mars image in here. We can play it. This clever program will align all these pictures so you see the frames jumping about. The Mars will be centrally placed. We have various options. If we were imaging the sun or the moon, we press image stabilization. Because we're using a planet, we press the planet button. We then press the Analyze button. Now the software will run through, it probably takes a minute or two, to analyze all these different frames, align them, and stack them. Those steps we have to go through to enable this. The output, the images will be stored as a TIFF file. Right, so it's done an analysis. The next thing we need to do is to place what we call an AP, an active point grid. And that puts little red dots all over the planet. And we put them close to the edge. Okay, I'll try again. And that will allow the software reference points to stack all these images. You want between 50 and 100 active points on a typical planetary image. The other thing we can do, you can see these little buttons here, is a box called Drizzle. Drizzling allows you to resample at a larger scale. It was developed for the Hubble Space Telescope. It allows you to resample a larger scale without showing pixelated images. Obviously, if you enlarge a small image, it will appear very pixelated. This resamples it, and it's best to use 1.5 rather than 3 times. We then press the stack button. It's now going through the stacking process. This sometimes takes a minute or two. So once we've done this, we'll then use a little program called Regis 6. These are all freeware programs, readily downloadable. So all you need is a small planetary camera, a telescope, and the software is all free. One thing I've omitted, you do actually have a choice of how many frames you put in your stack. This little quality graph shows better quality images at this end. I've elected to use 75%, and then you tick the little box in here. You can set this line by using control left click the number of frames you want stacked. The RGB align button will align the, note at the top you have a reddish fringe and a bluish fringe at the bottom. This of course affects our atmosphere, and the RGB align button will automatically shift the red down and the blue up, so you should get a slightly crisper image. It will also save the image in the original folder from which it found it, and it will be stacked in a little folder called AP75, representing the number of percentage of the frames that we use to make the image. So we're nearly there. Okay, so it's now finished processing, and we go to Regis and we select our stacked image. Right, the first thing we want to do is go to the wavelets page. We're not using Regis to stack, we've already done that, we've aligned them. So we're just going to use little sliders. These sliders represent, imagine, layers of the image representing the finer detail is the top layer and the coarser detail is the bottom. I normally start with the second slider down, and if you slide it across, you'll see a little bit more detail coming in here. We've got a bit of a fork here in the sinus, yeah. But of course, the more you use these sliders, also the more noise that's going to appear. This speckling here, you can see, is not natural. So you can play about with these until you're satisfied. There's not completely the end of the story. We've got a fair bit of detail here. We can remove this noise and crisp it up a little bit more with a further program called Denoise AI. Let's start again. We're going to open the image, So this is our resulting image from AutoStackert. See, with a little bit of noise here. And we're going to use, you can see these sliders here. We can remove the noise or we can sharpen. You want to start off with towards the low level because you don't want to overcook it. So generating a preview, and here you can see it's kept all the interesting detail, but the little speckly natures, this noise, has been removed. You can use this sharpen button as well. So there we have it. You can see this image is definitely improved from that one. Okay, so now we've got an image of Mars. Let's try and identify what features we're actually looking at. We've got the date and the time. All we need to do is use one of the little Mars previewing app, which is on the BAA website. Oops. Shrink it down there. So you enter the date and the time. Here we are, the 1st of September. We were imaging at 2 o'clock BST, so it's the time in universal time, so 1 hour earlier, 1 hour UT. These were all images taken by Damien Peach last year. So obviously we haven't gone up to his standard, but we can recognize some of these features. This is the Mare Cimerium with these dark features here. Down here we have Elysium. This is one of the giant Martian volcanoes. You sometimes get clouds appearing over Elysium. And the very shrinking now South Polar Cap. So I think you can see from rather a little fuzzy Mars image we had before, we have succeeded in showing you some detail. So there'll be more Mars imaging over the next few weeks. It will be getting nearer to us. It reaches opposition in a month or two's time. So happy Mars imaging.